Here we're simply using a formula that's provided to us to calculate the curvature of an ellipse. So our ellipse is given as r of t equal to 6 sine t. So that's going to be f of t in our formula, comma 5 cosine of t. That's going to be the g of t in our formula. So we're deriving f, we're deriving g, doing that twice for both, and then plugging that back into the formula. That's all we're doing. So f prime of t, that will be 6 cosine t, f double prime of t minus 6 sine t, g prime of t is minus 5 sine t, g double prime of t is minus 5 cosine t. So when you plug that back, all of that back into the formula that you see on the screen on the left, you'll have that k of t, the curvature, is the magnitude of f prime, g double prime, minus f double prime, and f double prime is negative 6 sine t, and g prime, which is minus 5 sine t, all that divided by f prime squared, so this thing squared, plus g prime squared, this being a 5 there, to the 3 halves. So the bottom can't be made any better, or maybe a little bit. Maybe you could write this 36 as 25 plus 11 and put the 25 cosine together with the 25 sine squared to maybe get a, at the bottom that will be an 11 cosine squared t plus 25. So that's the best it could possibly do. And again, that's by writing this as 25 cosine squared t plus 11 sine squared t, and then grouping this cosine squared with this sine squared to get a 25, and then the 11 being left. And that's a cosine, of course. And for the top, you'll have a 30, negative 30 cosine squared, and a, again, minus with minus a plus with a plus minus, another negative 30 sine squared. So finally, if you factor out a negative 30, that will be this entire thing here equals negative 30, and the absolute value of that is just positive 30. So the answer is this.